Hi, welcome to this HL7 FHIR DevDays community talk on democratizing FHIR with GraphQL. I'm Matt Bourne, I'm CTO of Tiny Medical Apps. My background is as a systems developer in the National Health Service, where I was working with clinicians to develop patient record systems. I'm now working with patients so they can access their health records and contribute back to them. This year we've been lucky enough to receive a grant from Innovate UK to help us work with digital companies who are trying to read and write to the health record and to see if we can remove some of the barriers that they face. This talk is going to focus on one of the key barriers to non-domain experts, namely being able to use and understand FHIR. Can we provide easier to grasp, friendlier, more accessible APIs in front of FHIR resources using GraphQL that cover common use cases and keep front-end code dry? I'm also going to try and make the case that expanding the opportunity for non-healthcare specialist tech companies and developers to build innovative interfaces is essential if we're going to help healthcare systems respond to the ever-increasing demand, and how this fits into a general trend towards moving resources downwards, away from hospital specialists to the community with patient-facing citizen health, as well as general technology trends towards encapsulating complexity and ultimately providing low-code and no-code development environments. The underlying challenge I see, and this comes from decades working in health tech, is that our industry is really not delivering on the potential of digital modernization. We're not creating enough new and engaging applications for clinicians or for patients from the wealth of rich data that hospital systems hold. We're struggling to provide mainstream excitement over new entrants in health tech in the way that, for example, fintech is now beginning to do. And this has a huge real impact in terms of the cost of healthcare and of patient outcomes. There are many reasons for this, and I'm not going to dwell on them, such as regulatory barriers, resistance from large vendors, but I want to focus on a more positive aspect that we can all be working on if we want to revolutionize health tech. We need to vastly increase the numbers of companies building solutions into healthcare and vastly increase the amount of front-end and back-end developers who are playing around with healthcare APIs. So something that policymakers have begun to start trying to grapple with in the face of ever-increasing cost of healthcare and somewhat stagnating outcomes is that maybe we should reverse the tendency of healthcare systems to focus resources on acute hospital care towards improving overall public health. This has led to a movement called Shift Left, where there is an attempt to reduce hospital activity by increasing primary care activity and to reduce primary care activity by increasing community and public health activity. And part of this is utilising remote monitoring and improving patient-facing digital support platforms. In this way, I see a direct parallel between providing a greater focus to non-hospital-based interventions and a greater focus towards increasing participation outside of existing health tech companies and healthcare engineers to build these new citizen-facing health platforms. In the same way that hospital beds and hospital-based healthcare specialists are an expensive, limited, and hard to increase resource, the same is true of healthcare engineers and health tech specialist companies. There's also a parallel that the kinds of innovation we need in public health is different from what is core to the existing healthcare industry, and the innovation likely lies outside of it. However, if we are to provide a way to open the door to non-healthcare specialist digital companies and developers, we must provide elegant, accessible APIs, middleware, and tooling that allows these new entrants to focus on patient-facing innovation, not grappling with the largely solved problem of interoperability. GraphQL provides a flexible way to smooth out a lot of the learning curve associated with FHIR by creating middleware that shapes data from a patient-centric and developer-centric perspective, rather than addressing system-to-system interoperability. So this talk is not specifically about the benefits of using GraphQL over traditional REST APIs. There's plenty of material about that on the web. But an aspect that I think is interesting and relevant to the discussion of using GraphQL with FHIR is that at the heart of GraphQL is the concept of resources and their union with other resources. For example, to be able to make a single call to pull down posts and their associated comments, and perhaps the associated likes on those comments. And this concept is, of course, something that maps well to FHIR resources and the frequent use of bundles to pull down collections of resources. However, it solves a big problem, which is the significant overfetching involved in a FHIR bundle REST request, particularly from the perspective of a front-end developer who perhaps only wants a few fields from that large bundle response. However, I am more interested in the value of being able to use GraphQL as either a middleware or perhaps even a front-end SDK to build custom, opinionated, low-level APIs addressing front-end developer use cases. I want to start by giving thanks to a great open source library, GraphQL Mesh, from the Guild, that provides a backbone to our GraphQL FHIR interfaces. So what is GraphQL Mesh? GraphQL Mesh is a library that can convert non-GraphQL data sources, such as Swagger OpenAPI, into a GraphQL endpoint. It has handlers for many data sources, such as relational and non-relational databases, and any JSON REST API. Crucially for us, it also has a handler for FHIR. It uses introspection to build these endpoints based on schema which it can build automatically from the original endpoint. It is not feature complete, and it's not a compliant FHIR standard GraphQL interface. However, it does use introspection to build a comprehensive list of resolvers based on the FHIR service conformance statement. Although GraphQL Mesh provides a great starting point by doing the heavy lifting of converting FHIR REST API into a GraphQL endpoint, it's still basically pushing and pulling FHIR resources in a standard FHIR way. Our aim was to move towards providing GraphQL queries that were designed for front-end developers' common use cases, not the requirements of system-to-system interoperability. Okay, so let's get stuck into some GraphQL. First thing to say is we're looking at something called a GraphQL Playground. It's a graphical IDE for exploring GraphQL endpoints and is provided as part of the GraphQL Mesh library. So, as you can see, it provides a very comprehensive automatic documentation, and because the GraphQL Mesh FHIR handler is pulling data from the conformance statement, you can see it's very detailed and defines and describes every field that is made available through FHIR. So let's have a look at the queries. So we'll start with a medication request. We're only going to receive those field data points that we've requested. That's the standard way of doing things in FHIR. But other than that, you can see it looks very much like a FHIR resource. If we hover over a field, you can see that it's pulling out the description from the FHIR conformance statement. Let's look at observation. As you can see, this is an observation by patient request. And again, it's only pulling out data that's listed in the query. But other than that, it's looking very much like standard FHIR response. So we believe we can go a step further than that to make this accessible to front-end developers who don't have a working knowledge of FHIR. So in this use case, we've created this custom query around the needs of someone building a medication request. For example, to list medications within a table in the front end. We've created these two new fields, medication name, which is mapping directly onto entry resource medication codable concept text, which we think is a bit more readable, and instructions, which is doing something a bit more sophisticated. It's pulling down all sorts of information from different fields within the medication request resource in order to do something that we think front-end developers will probably want to provide to the person reading this, which is, detailed instructions of what the medication is, when it's starting, and for how long. But because we know that front-end developers will probably want to dip down into the raw FHIR as well, you can, in the last field, create a list of FHIR fields that you want from the original resource. So let's look at another example of this. This is for peak flows, average peak flows, it, as you can see, it is providing a lot more than just the average score and the date. It's also providing things we know are useful when charting with peak flow, i.e. best value, 80% of best value, and 50% of value, which would trigger a red warning, for example. And the scores are down here. And you'll see how with these two custom requests, we're going to use them in the next slide when we look at a custom component built with these two queries. Okay, so what can we do now that we've tamed some of FHIR with GraphQL is we can take it a step further, make it even lower level by putting those GraphQL queries and encapsulating them with a no-code UI component, such as these components that we're going to take a look at, which are being delivered via Elementor via WordPress. So we have two components, one is a data grid and one is a chart. And we can configure them by going into edit the Elementor components. And by selecting the component, our configuration options will appear here. And we can do things like choose whether to wrap the text or not. Here we're choosing not to wrap the medication name. And we'll choose to wrap the instructions. And of course, it has all the options available to a data grid, like being able to filter, and we can also filter by date. So let's change the theme. We'll go from dark to light, and we can also look at some of the options within the peak flow chart. So if I select the peak flow chart, I can, for example, edit this subtitle and decide to show a legend. And let's change some of the options here. For example, with this line, we could change the marker to be a circle, maybe make the width of the line slightly bigger, and format the label. And I'll make a few other changes. For example, 80% of best value. Let's change that label. And because it's indicating something which is a warning, we're going to turn it into orange. And we're going to go into 50% of value, which is a significant warning. So we're going to turn this one into an indicator of red. If your peak flow is 50% of the best value, that is considered something that needs attention urgently. And maybe we'll make line 5 slightly easier to see, which is the average value of your peak flows over time, and we'll make that 5 pixels. So now we're beginning to create a no-code environment for someone creating an interface for FHIR resources. And just to demonstrate that these are drag and drop components, we'll add another peak flow chart onto the page, and it will appear with the default values within it. There you go.
Hello, Matt. Looks as though this is Sadhana Alangar, HL7's Director of Education. Looks as though there are not any questions here. Would you like to make some closing remarks?
Okay, yeah. I mean, I think just because I did slightly run out of time to summarise at the end, so I guess I would just say I think what I was trying to hopefully drive at is, you know, FHIR does this amazing job at kind of working at a system level, system to system interoperability. But what I'd like to see is kind of a focus on, you know, what do I as a patient need if I'm seeing that data coming to me from my health record? And of course, then you're starting to talk about how do you visualize this patient data in a way that's meaningful, give insights into it. That's why I was focusing on the 50% and 80% of best peak flow. But also the front-end developer. You know, I think if you come low enough down, the front-end developer is almost a creative. And so their job really isn't to be a healthcare engineer that really understands FHIR. It's to have APIs that are already providing them data in a really meaningful, accessible way to provide that useful information to the patient. And that's really what we've been driving towards.
Thank you. There's one question here, which has just come in. How long did it take to modify GraphQL Mesh for this project? How viable do you think it is in production?
Yeah, so I think there is a big issue around, you know, if you look at the FHIR documentation, it says, you know, this is what a GraphQL standard implementation, compliant implementation will look like. And I've not seen that available. I know there are people who are working on that, but they all seem to be projects in progress. So if people think there is something similar to that, you know, nearly available in production, you know, I'd love to hear about that. And I think it's necessary because the kind of stuff that we're doing is really wanting to build on top of that. You know, we're a small company and, you know, we're not going to be solving that problem. We want to solve a more focused problem. We were able to use Mesh because it kind of provides us a starting place. But I would say it's more kind of proof of value at the moment. There are components, for example, the GraphQL Mesh library doesn't handle mutations. And even in terms of just pulling data down, there are things that it doesn't quite do out of the box that you would be able to do with REST. So I think either the Mesh underlying GraphQL Mesh handler for FHIR needs to be kind of fully mature and more resources put into it, or perhaps there'll be an alternative that could be used. But in terms of what we were able to do for this presentation, you know, generating those custom queries, you know, it was a couple of days' work. It wasn't a massive amount of work because GraphQL Mesh has done such a great job of basically translating every FHIR resource into a GraphQL endpoint. We're just creating a custom resolver where we're saying, okay, this still looks a lot like FHIR, so you're going to have to understand FHIR to use this. Whereas what we want is to say, what if someone wants to chart peak flows, what is the kind of endpoint they're going to want to look at? And all the custom resolvers in front of the GraphQL Mesh resolvers, you know, was a few days' work, not a lot more than that. And we were able to turn that into the Elementor customizable no-code component in another day or two, because it's using a library that's designed to do that already to create custom components. So we're basically just linking the data to the GraphQL queries. Yeah.
Thank you so much, Matt. There's one more question, but I think we are out of time. Maybe you could just answer in the...
I can go on Hooview and answer questions there as well.
Okay. Do you want to take a shot at this? How would this work with FHIR profiles? Example, adding extensions and exposing to GQL Mesh.
Well, I think this is why, you know, it'd be great to see, you know, the guild, who are the organisation behind GraphQL Mesh, have done an amazing job. I think they probably need to work with some, you know, some kind of FHIR experts to help make it more a conformant library. And all those things are technically doable. I think it's just about putting the resources in. But for us to take it a stage further and do interesting things on top of that, obviously we want a fully compliant GraphQL FHIR interface, and we'd love to see that being developed.
Okay, thank you so much. Thank you for answering all the questions and for that excellent presentation and demo. Thanks everyone for joining us. Please don't forget to rate this session. This is Sadhana Alangar, HL7's Director of Education, signing off. Bye everyone.